Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to our midterm exam presentation for PBL RKS 603. My name is Fadiananda Maulana as the leader of this team. First of all, on behalf of our entire team, we would like to express our deepest gratitude to Mrs. Festi Windasari as the project manager of our team. Without further ado, we will present our project titled Design and Evaluation of Green Cryptography Index for Assessing Energy Efficiency of Cryptographic Algorithms on Low-Power IoT Devices. Before we begin, allow me to introduce our team who has contributed to our project. First is our project manager that I've mentioned before, Mrs. Festi Windasari, followed by me, Fadiananda Maulana as the leader. Second one is Reva Zuranti and then Nafis Azamsyah, followed by Muhammad Brahma, and last but not least, Muhammad Syauki Akbar. Now let me walk you through our project introduction. So what we do in this project, our project designs and evaluates a Green Cryptography Index or GCI, an objective metrics to measure the energy efficiency of cryptographic algorithms running on low-power IoT devices. We test 5 algorithms on a Raspberry Pi, such as AES, SPECK, Present, ASCON, and ECC. And we measure 3 key aspects such as energy consumption, execution time, resource usage, RAM and CPU. With the expected outputs of this project, such as the Green Cryptography Index, a scientific research paper, and also an energy efficiency benchmark report. This output will contribute to the growing field of sustainable and energy-aware computing, especially for research-constrained IoT environments.
Thanks, Fadiananda. Next, this slide presents the technical architecture of our research system. Our system is deployed on a Raspberry Pi on ARM Cortex-A72, running Debian Linux as the representative low-power IoT device in the study. The architecture consists of 3 layers. At the top, the Python measurement harness controls the experimental procedure, running 1000 trial with 50 warm-up iteration per algorithm, capturing latency from usage and throughput, then exporting the result as CSV datasets. In the middle, the C-type bridge connects the Python harness to the C implementation, ensuring that measurement reflects the true performance of each algorithm. At the bottom, the C cryptographic engine layer contains all 5 algorithms compiled as optimized share libraries, like AES 128 CBC, ASCON 128 AEAB, Present 80, SPECK 64 per 128, and SCCP 256, each producing CSV outputs that fits into the GCI computations. Next, this slide presents our project progress as of the midterm evaluations. The project has currently reached 57% overall completions. 2 phases have been successfully concluded: design and planning, and implementation, covering the research framework, algorithm selections, and development of all 5 cryptographic engines on the Raspberry Pi. The project is currently in the testing and benchmarking phase, where encryption benchmarking has been complete and decryption benchmarking remains ongoing. Going forward, the team plans to complete the full benchmarking cycles, perform statistical analysis and GCI computations, conduct a comparative efficiency analysis, and finalize the research paper and project report. With the benchmarking infrastructure fully in place, the team is confident in delivering all remaining outcomes within the designated timeframe. Next slide will explained by Muhammad Syauki.
Right, I will be explaining our progress of the PBL project up to mid-semester. As for our progress, we have our own project directory in our Raspberry Pi with benchmark results as forward. Then, as the algorithm implementation, we have the AES and core and the code, the SN core and the code, and the ECC core code, the SPECK core and the code, and our SPECK core and the code. So we have also our own. We have the last is our results of the few of our codes of the implementation of the algorithm, as we can see here, and uses some Pi and some form of C code.
Okay, project progress, algorithm implementation, SPECK, and for the result. So in the left we saw the SPECK core and SPECK code, and for the right side there is a result for implementation of SPECK. Okay, next, job desk distribution. Here we show the job desk for each member. First is Fadiananda Maulana for algorithm ECC, Reva Zuranti ASCON, Muhammad Brahma Panjabuana Present, Nafis Azamsyah SPECK, and Muhammad Syauki Akbar AS. Its member is responsible for implementing the C engine for their assigned algorithm, developing the measurement script, conducting encryption and decryption testing on Raspberry Pi, collecting and managing measurement result data in CSV format, and explaining the algorithm in the report and presentation.
Okay, this slide show our project logbook up to mid-semester. It includes the planning, implementation, and testing phase. We also track progress, timeline, and output for each stage to ensure the project is on track. And for our constraint, in this project, we face several constraints. First, limit research on IoT hardware. Second is maintaining consistent testing condition. We also have limit research reference on green cryptography. Additionally, there are high computational difference between algorithms. And finally, benchmarking and data collection require significant time.
That's all for our presentation today. Thank you so much for watching. We hope this video gives you a clear picture of our project and its goals. Any question or feedback are very welcome. Please reach out to our team. Once again, thank you and see you on next presentation.